In this video, we want to look at a couple different kind of trig identities. The first are known as the sum and difference identities, and then the second kind we're going to look at is called the double angle identities. Now, both of these identities, we just want to kind of show you, these are things that you would look up. I would not expect anybody to kind of remember these long term, but these do come up, I know, in calculus and other classes where we have to kind of pull them out to use them at certain situations. So I want to go over them just to show you they exist and just kind of get you familiar with them. And we're not going to do a lot with them here. So first, I want you to look at this idea. If we had the cosine of u plus v, such as the cosine of 30 plus 60, would that be equal to just the cosine of 30 plus the cosine of 60? Can you split up a trig function like that? Well, if we think about that a second, let's just think about our values that we know, and I'm going to pull these off our unit circle if you remember those. If not, just you can trust me here. If we had 30 plus 60, that would be 90. So cosine of 90 is, what is the x-coordinate at 90, which is 0. Cosine of 30 is the x-coordinate at 30, which is square root of 3 over 2. And cosine of 60 is the x-coordinate of 60, which is 1/2. So obviously, we get square root of 3 plus 1 over 2, if I add those fractions, does not equal 0. So these are not equal. We cannot take this cosine here and just split it into 2. So how do we do this? That is going to be our sum and difference formulas. So let's work through this to kind of show you what this means. If we had the sine of u plus v, two angles, then we'd have the sine of u, cosine of v, plus cosine of u, sine of v. And similarly here with cosine. Now notice cosine switch. With sine, if it's plus and minus, it stays plus and minus. Cosine, if it's plus, then it has to get flipped to minus. So what that would mean is if I would go back to here and I look at what is cosine of 30 plus 60, my identity here would be cosine of 30 times cosine of 60. It's plus, so it switches, and I get minus sine of 30 cosine of 60. Oops, excuse me, that should be sine also, so that should be sine. Now, if you go to our unit circle again, cosine of 30, as we said, is 1/2. Cosine of 60, excuse me, cosine of 30 is square root of 3 over 2. Cosine of 60 is 1/2. Sine of 30 is 1/2. Sine of 60 is square root of 3 over 2. And then you can simplify, and you see here, you're going to get square root of 3 over 4 minus square root of 3 over 4, which if you see, if I subtract those, I get 0, which is what we looked at a second ago, that if you get 90 here, that should be 0, which is what we got. Okay. 0 here, 0 here. So we just want to kind of get comfortable using these identities. So let's look at another example. Cosine of 15. Now what you want to do is you want to think of two angles that give us 15 that we know from our unit circle. And there's lots of them. We could say, you know, and I'm just going to mainly stick with angles less than 90. So I could say 60 minus 45 or 45 minus 30. Both of those would work. Now, you could go something bigger, you know, 150 minus 135 would also work. We're going to kind of stay here. And I think I'm going to use the first one. So this would be equal to cosine of 60 minus 45. Now, from our minus, it becomes a plus, cosine, cosine. So this is going to be cosine of 60, cosine of 45. It's a minus, so it becomes a plus. Sine of 60, sine of 45. Now, from our unit circle, cosine of 60 is 1/2. Cosine of 45, square root of 2 over 2. Use your unit circle to help you here. Sine of 60 is square root of 3 over 2. Sine of 45 is square root of 2 over 2, which is going to give me square root of 2 over 4. Plus, when you multiply what's underneath the radical, square root of 6 over 4. So my answer here is square root of 2 plus square root of 6 all over 4. Now, let me kind of just show you what we did here. So with what I have here, if I have the square root of 2 plus the square root of 6 divided by 4, I get to there. Now, if I've done this right, cosine of 15 should be the same thing. And you see we get the same exact answer there. So we've used the identity to help us simplify. So what we're really trying, now I know, we could just type cosine of 15 into our calculator, obviously. This is more about us understanding these formulas. Let's look at another one. If I have sine of pi over 4 cosine of pi over 5 minus cosine of pi over 4 sine of pi over 5, how can I simplify this into a single sine and cosine? Well, the first thing you want to decide is which one of these is it? Is it a sine or is it a cosine? We're really not going to use tangent much here. So is it a sine or a cosine? So when you look at it, you get sine, cosine, cosine, sine. That tells us it's a sine. It is a minus in the middle. That tells us it's a plus for sine. So that tells us this is sine of pi over 4 plus, minus, sine's the same, minus pi over 5. Now, it's hard to tell here, but pi over 4 is 45. Pi over 5 is 36. So this is actually equal to the sine of 9. Now, that's a little bit hard. I just want to do a little refresher there on radians. Let's do one with degrees. So here's how we would do this. Cosine of 20, cosine of 35, sine of 20, sine of 35. So the first thing you want to look at, is this a sine or is this a cosine? And because it is cosine, cosine, sine, sine, that tells us it is a cosine problem. And the sign changes in the middle. So if this is a cosine problem, this is going to be the cosine of 20 and the cosine of 35. This is a minus, so this is a plus. So this is equal to cosine of 55. And like I said, this is just getting us used to how to use these identities. Now, let's say we want to kind of use our prove a trig identity. So let's say we want to look at what is cosine of x plus x. Or this would be cosine of 2x if we want to think of it as a double the same angle. So if we come back over here, cosine plus is cosine, cosine, sine, sine with a minus sign. So that means we are going to get cosine of x minus sine of x sine of x. So we end up with cosine squared of x minus sine squared. Now, that looks really close to 1, but that's if it's an addition. Subtraction, there's nothing we can do. So if we do that idea, we can generate all of our double angle identities. And here are our double angle identities. Sine of 2u is sine 2 sine u cosine of u. We just proved this one. Cosine of 2u is cosine squared minus sine squared. These other two come from these. I think you can kind of see if I would change sine squared to 1 minus cosine squared, I could get that one. If I change cosine squared to 1 minus sine squared, I would get that one down there. Now, I'm going to skip that one. I think we could understand the proof. We would, well, let's kind of go through it here. So if we do this, we have our cosine, and this is going to be from our previous, we are going to get cosine squared minus sine squared. That is what we did on the first example. Back here. Right there, cosine squared minus sine squared. Now, if I change my sine squared to 1 minus cosine squared from our fundamental trig identities, you can see this is going to be minus and plus, and so we are going to get 2 cosine squared minus 1, and there is what our identity should be. That's actually incorrect there. This should be 2 cosine squared minus 1. Had it written down wrong there, and the identity was written correctly back here. Also on our fundamental trig identity formula sheet back here. The last thing we want to do is we want to use these identities with a triangle. So let's say we have this right triangle. It's a 3, 5. So then we know that this other side is a 4. And so we want to find what is 2 sine of theta. So that's from our identities. This is going to be 2 sine of theta, cosine of theta. So that's 2 sine of theta is 3/5. Cosine of theta is 4/5. And if we multiply that out, we're going to get 24 25ths. Let's get tangent. Tangent, you can do it 2 ways. There's 3 ways, excuse me. I am going to do cosine squared minus sine squared. Cosine is 4/5. Sine is 3/5. So this gives me 16 over 25 minus 9 over 25, which is going to give me 7 over 25. So these are very similar to the problems you are going to see on the homework. You are going to see doing these kind of triangles. We're not going to do tangent with the sine and cosine. We're going to be proving some simple trig identities using these for double angles. For our sum and difference, we're going to have an expression like this that you have to write as a single expression by determining is it sine or cosine, plus or minus. And then we're going to have a couple where we have a number like 15 where you have to figure out how can I use this to find my unit circle values by adding and subtracting. Okay, try to just use your angles between 0 to 90 to make it easier. All right, you are now ready to do your homework over the sum and difference identities and our double angle identities.